Good morning, everybody. Welcome, Guildford. Woo! We've got a pretty full agenda today, so I guess, first of all, thank you ever so much for taking the time out of all of your busy schedules for being here today and helping us celebrate the opening of this new, wonderful, state-of-the-art facility for us as Element and specifically for connected technology. We've got quite a range of presentations that we're going to do today. We've got 4 presentations, a lot of focus on radio products, but in essence, our job as Element in connected technologies is to help manufacturers get their products to market. So the technical presentations that we'll hear and listen to later on support some of those activities in terms of what you need to do to get your product onto the market and to keep it onto the market, and some of the things that you need to do to support that as manufacturers. But ahead of all of that, we are going to have an opening address from our CEO, Joe Wetz, and then some of the dignitaries which will be introduced in due course. Before we kick off, just a little bit of housekeeping. If you've got a mobile phone, please could you switch it to silent or switch it off, just as a courtesy. That would be fantastic. In terms of fire alarms and safety, safety is is the first core principle that we have in Element. So we take safety absolutely seriously, underlined by the fact that the whole of that world is about making tomorrow safer than today. So with that in mind, I just wanted to inform you that we don't have any fire drills. So if you hear the audible fire alarm, it means that there's a real fire. There's some fire exit signs here on your right, and then through here on the left, there's also another fire exit as well. We have fire marshals, they will guide you out the building, and the muster point is actually straight outside the front of the building itself. There are people walking around with blue lanyards on. That indicates that they work for Element. So if you get lost, need to know where the restrooms are, or have any other technical or organizational questions, then feel free to go and collar somebody who will then be able to help and support you. In terms of the restrooms facilities themselves, you pass them on the way to get into here. So they're back through these double doors here, make a right, and they're straight in front of you. If all of those are full, then in the reception area where you first registered, there's some additional facilities there as well. In terms of the technical presentations, as I mentioned, we've got 4 presentations, and rather than taking copious notes, feel free to do that if that's your thing, but equally, we'll make sure that those are available to you afterwards for download, or we'll email them to you as well. So don't stress about taking notes as and when. So I think then as a next step, I'd like to introduce Joe. Joe Wetz is our CEO of Element, and we'll take it from there. Over to you, Joe.
Thank you, Steve. Thank you, Steve. Steve is one of our world-class experts. Clearly has got a highly valuable fallback career as an MC if that doesn't work out. So thank you, Steve, for introducing us. My name is Joe Wetz. I'm the Element CEO. I've been with the business now for 13, 14 years. And it's with great pleasure that I welcome you to our Centre of Excellence for Connected Technologies in Surrey Hills. This is the culmination of a huge amount of work over the last 24 months. And I want to start with a couple of welcomes and thank yous. I'm then going to introduce Element a little bit. I won't spend too long, talk a bit about Surrey, and then I'm going to hand over to Matt Hopkinson, who runs our EMEA business. So firstly, I'd like to welcome Lord Lindsay, who is the chair of UCAS, which is the UK Accreditation Service, an absolute critical part of our ecosystem as a laboratory business, both in the UK and globally. So thank you for joining us. We've got Jonathan Lord, who's MP for Woking. Thank you, Jonathan, for joining. I know that you will be incredibly busy at the moment and probably didn't imagine that this was going to fall in the middle of a general election. So we appreciate you joining us today. We've also got representation from the Surrey and the British Chambers of Commerce, so we welcome you and thank you for joining. But I really want to start with thanking you, our customers and partners, for traveling here today to share with us the opening of the facility, to see the services that we're able to offer. As Steve said, you've got incredibly busy agendas, so actually joining us and taking the time and hearing some of our technical presentation is greatly appreciated. In terms of other thank yous, I want to thank Paul Blackett, who's sitting at the front on his own here. He's our GM for the facility. The rest of his team are hiding at the back, but you're going to be able to spot them with the blue lanyards. That team has done an amazing job in getting us up and running in record time. And I think you'll see that when you go round and visit the facility, but the technical competence of the team, also the scale of the facility, the fact that we're here opening it after just 2 years is an incredible achievement. So thank you, Paul, and the team for all the hard work. As a final thank you, I'd like to thank the events team. A huge amount of work has gone into today. The building looks fabulous, but you've really tuned it up so that we can welcome our guests and have a fabulous event. So thank you for everything that you've done today. A couple of brief words on Element. All of you know us in one capacity or another. But in many ways, we're I guess, an under-recognized or understood British services success story. So we came out of a large Dutch corporate as a relatively small business 12 years ago. We had 600 colleagues, we had 20 locations in 5 geographies. And over the last 13 years, we've grown significantly in supporting our customers in highly regulated end markets, all the way from aerospace to medical devices to connected technologies, through to the automotive industry. And we now do that in 270 locations in 30 geographies with over 9,500 colleagues. So it's been a remarkable last decade. And if you need other services in other parts of the world, we will undoubtedly be able to help you outside of Surrey Hills. So if I turn to Surrey Hills, this is a $10 million investment that we've made in building this facility today. I'm told very clearly by the team it is phase 1 of a series of $10 million investments that they want to make in terms of growing our capability here. We're focused on consumer technology, medical device, a connected technology world, and hopefully you will stay and enjoy some of the technical presentations that Steve and Simon will be giving later today. Why did we make a $10 million investment as stage 1 of our multi-stage rollout behind these industries? Well, your industries are incredibly innovative. You're all operating in highly regulated end markets, and you need to access multi-geographies. And we have deep capability both in the US and Korea, as well as a footprint in the UK. But this was a very, very natural extension for us. And we see the opportunity to support you as customers in building your products and accessing markets all over the world from here in Surrey Hills. So I'm not going to go on too long about Element or Surrey Hills. I'm now going to hand over to Matt, who will tell you a little bit about the journey and how we brought this to fruition. And I look forward to meeting and speaking to many of you over the course of the morning. Thank you.
Good morning and welcome. So I am Matt Hopkinson. I am the Executive Vice President for Europe, Middle East, and Asia for Element. I have been in Element now for 6 years, so I've witnessed about half of the journey that Joe mentioned, and I've aged 20 years in that time, so I can only imagine those that joined the business right at the start. I wasn't going to mention the hair, Joe. You went there. I think the first thing I'd say is actually it's a really proud moment today. I think Joe's said the thank yous. There's a huge amount of work that's gone on to come here and build this business. Over the last 10 years, Element has really grown strongly, and they've grown strongly in 2 ways. We have bought and acquired loads of businesses that really fit the model that we have, which is providing technical testing services into critical, safety-driven end markets. But we're also a business that really wants to invest and grow organically. And throughout the world, we are building laboratories to really make sure that we're at the forefront of technology. And what we see here in Guildford and the lab that we call Element Surrey Hills is really a manifestation of that for the connected technology end market and to hopefully to support all of you. The purpose of Element, again, you'll see it all over the walls. If you haven't seen it yet, you definitely will, is making tomorrow safer than today. This is a thread that runs through all of our businesses in all of our geographies, in all of our end markets. That is underpinned by 3 core values: integrity, that we do the right things; care, that we care about our own colleagues, we care about our customers, we care about the environment that we work in; and progress. And I'd just like to just lean on the third of those values today, progress. This was a site that really had, nothing in it 2 years ago. We're in a situation where there are laboratories elsewhere in the world that were providing support into UK manufacturers, and perhaps we weren't in a situation as Element, or perhaps as a broader industry, where we were really pushing the UK at the forefront of technology. We've decided to invest. We've taken the knowledge that we have in other parts of the world, in particular in the US and in Korea, to try to bring it in here, both from an equipment perspective and a capacity perspective, but also from a technical expert perspective. And we see this as stage 1. I think there's a long way to go. The team around will say this is one of our 7 laboratories that sit within Connected Technologies in the UK. We've got a fantastic team of 400 people who are out there every day kind of supporting your business. So this wouldn't have been possible without the breadth and the scale of Element as a global company. I think it's one thing building the building, which is a lot of hard work and a lot of stress. It's another thing buying the equipment, but that technical competence that comes with that, and that ability to build that technical competence over a period of time is really critical. And so I think our ability to bring individuals in from different countries to train, to spend time here, to really work with customers, to build our competence over a period of time to get to the stage we are now is something that's quite unique and has been managed incredibly well by the team. I'm very proud of that. I think within that same theme of how do we kind of create a real technical leader in the UK, we had many choices when we were looking where to build this laboratory. When you build a laboratory from scratch, you can choose where to go. We could have put the laboratory on the south coast. We had conversations about that. We could have put the laboratory in kind of to the north of London, and we had conversations about that. One of the deciding factors of coming here to Guildford was the proximity to the local universities, in particular to Surrey University, because it really gave us an ability to partner with those universities. We gave a great opportunity to students, and we're doing that consistently. I think last year we had 10 students come and work for us as they go through their studies. At the same time, that gives us a fantastic access to a pool of talent that hopefully when they graduate, then they have a place to come and develop their career and their technical skills and become part of a broader UK technical network. So we're kind of really proud of that, and that core value of care really comes in terms of the connection we have to that community, and it's something we want to foster as we go forward. I'm going to leave it there. Joe mentioned that UCAS is a really fundamental part of our ecosystem. We work very closely with UCAS. They both support us and provide kind of technical insight, but frankly, they also hold us to account to make sure that the work that we are doing is of the highest quality, to service each of our customers. And it's a real pleasure to welcome Lord Lindsay here to come and say some words. Thank you.
Thanks, Matt. Well, thanks, Matt. Thank you, everyone, for this invitation to join you here at the official opening of the Element Surrey Hills. So my name is Jamie Lindsay, Lord Jamie Lindsay. I'm the chairman of UCAS. I'm also president of the Chartered Trading Standards Institute and the Chartered Quality Institute. So I've got various things which sort of keep me out of mischief and keep me busy. But I've long been an advocate, a passionate advocate for technical innovation, and I've spent the last 3 decades pushing for better standards on quality, on safety, and on environmental impact, both within the United Kingdom but also overseas. So I was delighted to be invited here today in my UCAS capacity to this opening and to this new facility, and to be able to say a few words of welcome. As many of you will be aware, UCAS is the United Kingdom Accreditation Service. We are appointed by government as the United Kingdom's national accreditation body. And in short, our role is to check the checkers. Now, what that means in practice is that UCAS attests the competence, the integrity, and the impartiality of organizations that provide conformity assessment services, such as testing, inspection, certification, and calibration. And our assessments of sites such as this are made against a set of internationally agreed and recognized standards. And as a UCAS accredited test laboratory to the standard ISO 1725, Element Surrey Hills is now a part of this critical global quality infrastructure. And I think it's evident that it has never been more important for organizations to embed quality in everything that they do. There are mounting risks and uncertainties in today's world, but together, through quality infrastructure, we can embrace our roles as being guardians of safety, of security and sustainability to deliver a more confident and a safer society. And I think this is where, evidently, Elements and UCAS's worlds dovetail. Element supports customers in safety-critical industries. Element is committed to continuously evolving its capacity and capabilities to enable new innovative products and services to come to market. And they do that whilst holding to their purpose of making tomorrow safer than today and to their values of integrity, care and progress. At the same time, alongside Element, UCAS provides the additional layer of confidence underpinning trust in the work of Element and in their commitment and compliance with standards and acting as its quality improvement partner. So the establishment of this laboratory marks a pivotal moment for Element, and I recognize that. Indeed, I believe this sort of investment here in a new connected technologies centre of excellence has a much broader impact and a much broader significance. And I think we've heard from the speakers so far of that sort of global ripple. Element Surrey Hills is a beacon of innovation, where brilliant minds can converge to push the boundaries in consumer electronics, in medical devices, and wireless industries across Europe and further afield. And I was really impressed touring the facility this morning by the scale of the investment, the sophistication of the technology, and indeed the expertise of the team, and the vision that is so tangible as you spend time with staff members here and just absorbing the atmosphere and the messaging. There's real enthusiasm here and real aspiration. And I'm sure that Element will act as trusted partners for customers at the forefront of technology, working to make the world a safer place. I have to say in passing, because I thought it was hugely impressive, that Paul told me that they managed to do this build on a zero waste to landfill, which I think is an incredible achievement. And also, I think someone told me, Paul, that the carbon savings in this build were the equivalent to 2.5 million mobile phones being charged. And I just thought that was a rather nice record of what nowadays you can achieve if you really want to be safe and responsible. So, look, thank you. In conclusion, I would like to express my admiration for everyone who has put this place together, this site together, the company, the team here, and the sort of wider Element company team. But I think you are embarking on a journey here which involves exploration, it involves advancement, it involves quality enhancement. This is a road which is familiar to a number of UCAS's customers, but it is nonetheless one that requires the dedication and scientific expertise that you here at Element so evidently demonstrate. So you're on a great journey. You've got some great opportunities ahead of you. Embrace them. I think this is a really exciting location. You've got a really exciting team, and you're in a really exciting sector. So thank you for being involved in this opening ceremony this morning. I'm hugely appreciated, and good luck. Steve. It's Steve, yes, Matt.
Thank you ever so much, Lord Lindsay, for those kind words. So we're going to just move into an official ribbon-cutting ceremony now. So if I could invite our invited guests, Matt, Joe, up as well, and I shall pass over some. There has a safety assessment associated with the use of these scissors. Are you familiar with these?
I don't think
No,
I don't think I'm cutting. I think
and-
we're
and
going to
there's-
ask
The risk
Lord
assessment said there's only one person that can
Yeah.
hold these, so
Right.
maybe I could give you that
Right.
honour.
I would.
So maybe
Okay.
if you guys could move
Right, should we
forward.
just step forward?
Yeah,
Right.
Thank
Do you
you.
want me to?
Right.
Yeah, we've got a
Before-
second one just in
before-
case. If we get it wrong.
Right. Yes, yeah. Yes, nobody wants.
Actually, do you know, this is advanced.
And I think that might involve.
Excellent. Thank you very much. Fantastic. Yeah. Great stuff. Right, thank you very much for that. So in terms of the next steps in terms of today, we've got two technical presentations. I'll be giving one of them, and I'm going to be talking to you about integrating wireless technologies into IoT-type devices, and the requirements for both Europe, the USA, and a worldwide market as well. And then my colleague Simon Barrowcliffe is going to be talking to us about understanding of risk analysis in Europe, but actually from a societal perspective, the change in risk appetite and the requirements that move from very dictatorial regimes in terms of you shall do this to a shared resource in terms of you are the manufacturer, you're in control of your destiny, you understand the risks associated with your product. So Simon's going to do that presentation following me. Then we're going to have a break for lunch. Certainly from your point of view, being sat down for two presentations is a good opportunity to get up, walk around, have some lunch, and network with other people. Let's say a number of you in the room today are manufacturers. Some of you are actually manufacturers of radio modules, and some of you actually make host equipment that you want to integrate modules in. And if we can act as that dating service, if you like, between the two and marry you up, then that's a great thing. But really today is about learning and understanding what you need to do to get your product to market. Once we have a lunch, then we go for a little tour around the facility. For that, we're going to divide up into 4 groups. We'll go through that a little bit later on. And then when we've done that, we're going to come back for the final 2 presentations. Again, it's a bit of a double act, I'm afraid. So if you don't like the first 2 presentations, the speakers, then I apologize for what's going to happen later on, because it's a repeat of myself and Simon doing a presentation on market access requirements for Europe and some of the tests that support that. And then Simon's also going to go and talk about using an international scheme, the IEC CB scheme, to access multiple markets around the world. It builds on some of the things that Lord Lindsay was referring to a few moments ago in terms of underpinning a lot of what we do through international accreditation, and certainly testing that we do here in the UK, because it's based on international standards that allows manufacturers to export their products to a worldwide market. And this international recognition system, ISO 17025 for testing, 17065 for certification, underpins a lot of that type of activity. And then all being well, by 3:30 at the latest, you'll be in your vehicles, wheels spinning out of here, back to wherever you've come from today. So, I guess let's jump straight into it then. I didn't introduce myself before, but for those that don't know me, my name's Steve Hayes. I work in the Connected Technology Business Unit of Element, and my job is Technical Director. So I help try and identify the things that you guys need to do in terms of getting your products to market and support that with adding services that you need. And then from an internal perspective, coordinating what we do in this lab with many of our other labs, not just in the UK, but our labs in Germany, in Asia, and the US as well, to make sure that from a customer perspective, you have the same engagement, you're testing to the same things, and literally, if we banged you on the head and you woke up in one of our other facilities, the expectation being that you would have a similar experience testing in those locations as well. So, integrating wireless technology into a host product then. So in terms of what I'll be talking about, first of all, a definition of what radio equipment is. And now you may think that's slightly obvious, but depending upon where you are in the world, we view things slightly differently. And I'll go in, just touch on that a little bit. Then we'll have a look at European requirements for product approvals. Then North American, so North America predominantly focused around US and Canada. I don't think there's any other countries in North America, so that's all good. And then what you do, the process is, the mindset that you've got to have when you integrate a radio product into a host, whatever that host may be. And then really just some takeaway messages at the end to wrap up. So, in terms of radio equipment itself, I'm really interested actually. Forget the presentation, but just the technology for me to be up here and all of the other speakers talking to you, all with wireless technology, all supported by a desk over there without a single wire connecting the two things, and expecting 5 different radios to work in very close proximity to one another without causing interference. That underpins and illustrates exactly what our job is, to ensure that things can get co-located without causing that type of interference. So, when we think about radio equipment, we're thinking about Wi-Fi routers. We're thinking about walkie-talkie radios, one of my favorite topics for car parking. We're talking about radio modules. And in Europe, radio modules are radio equipment. So, what I'll come on to talk about in a second is how we view radio modules slightly differently in different regions of the world. Anything that receives broadcast signals, so transistor radio, that fly is really annoying, it's going to die. Transistor radio, satellite TV equipment, reception equipment of broadcast signals, we now consider to be radio equipment in Europe. In fact, we consider anything that either transmits, receives, or a combination of those, and determines things using radio technology as radio equipment. And that radio determination stuff, what I'm really talking about is in your car, if you've got a modern car that's got adaptive cruise control, for example, the radar and things like that. There's no communication there, but we're using a Doppler effect to identify targets and slowing the vehicle down, so radio technology. In Europe, I have no idea really why it happens, but people put radio technologies into things like trainers or sneakers for the US people in the room. There is a radio equipment in that device, that shoe. However, the shoe doesn't become a piece of radio equipment. Slightly obvious. A car is full of radio equipment, but the car also is not radio equipment as a whole thing. And I don't want to get stuck in the detail right now, but it gets very nuanced, right? because in a vehicle, if I just take that as an example, a vehicle from a regulatory perspective, from a legal perspective, is a piece of non-electrical equipment. Even if it's a fully autonomous electric vehicle, it's not electrical from a regulatory perspective. Why? Well, because it's just a piece of moving machinery, and actually, if you think about the brakes, the wheels, the windshields, all of those things, they're predominantly mechanical. So overall, from a regulatory point of view, a vehicle is not a piece of radio equipment. If it falls under the heading of type approval or type certification, as opposed to other types of machine which are radio equipment. Now, I've probably confused everybody enormously in that statement, and I'll unpick a little bit of that later on. So that's what we view radio equipment in Europe. So how does that vary or differ with the US? And the answer is, it's actually pretty much the same, except for broadcast equipment, reception equipment is not considered radio for the purposes of North America, US, and Canada. Everything else is pretty much the same. And of course, as manufacturers, what you want to do is design one product and access a global market. So one of the things I'm going to be talking about is what can you do to leverage the testing, for example, that we do here in the UK, in Surrey Hills, and access that global market. And the more similar those things are, the more countries you can access, and that improves your time to market, and it also reduces cost. Now, despite the fact I only look 25, I've actually been doing and involved in product approvals for the last 33 years. When I started as a test engineer all that time ago, in 1991, our job at the time was to test product for a British kite mark in the UK, take the product to Germany and have it tested for VDE standards in Germany, to ANFR in France for French approval. So you can imagine the time to market was extremely long. It was also very expensive, and you had to translate everything. Part of the European Union, free movement of goods, accelerated we need one system that enables one product to access all of these national member states. And that was the introduction of CE marking. So CE marking massively simplified the approval requirements, test once, and it's certified everywhere. Since Brexit, of course, CE marking is not adopted directly in the UK. We have our own UK regulations. We had a thing called the UK CA mark. The UK government stepped back from that a little bit now, and we accept CE marking in the UK. But fundamentally, it's one system. Whether it's a different mark or not, the tests that we do, the assessments that we provide, are all based on exactly the same requirements. Do it once and access all areas. So if I think about the US, there is some different terminology that we have to get familiar with. In the US, it's simple. Things intentionally radiate or they don't. So we have this concept of unintentional radiators. All of the classic IT equipment, digital devices, all of those things that have got a microprocessor in, effectively, if they don't intentionally transmit radio waves, then they are called unintentional radiators and have a set of requirements attached to them. The FCC in the USA, the Federal Communications Commission, are responsible for policing of the airwaves, if you like, to make sure that interference doesn't occur. And we have Part 15 of the FCC rules, which we test to here, that enables manufacturers to get their products tested in the UK and approved for the US market. On the other side, we have intentional radiators, those things which intentionally transmit radio waves, either for communication purposes or other purposes. Typically, we divide them into two halves. We have unlicensed transmitters, and unlicensed means you, me, us. We don't require an individual license to operate our device. This clicker, I didn't have to get a license from Ofcom today to operate it. it's unlicensed. Using your mobile or cell phone today doesn't require you to have a license. If, however, you make other types of transmitter, typically higher power, or it uses bands which are close to emergency services, or maybe emergency services themselves, then you require a license, and then we have different rule parts that apply to that. All of the testing, however, is supported by or underpinned by making sure that we don't cause electrical interference. So we have intentional and we have unintentional radiators, but in the real world, we just have IoT products, which are a combination of intentional and unintentional. Your laptop computer, for example, is an unintentional radiator when you're using it as a microprocessor, but then when you want it to connect onto the internet, using Wi-Fi, Bluetooth, whatever, then it's an intentional radiator. And so there's where some of the complexity comes into our world. We're dealing with a mixture of intentional and unintentional radiators, and that's just the world that we live in now. The reason why manufacturers such as yourselves come to people like us as Element to help is, first of all, as Joe illustrated, the amount of capital expenditure that you would need to invest to do this your testing yourself is so high, unless you were a very, very high volume manufacturer, you could never financially justify it. But more importantly than that, it's the technical expertise that understands these regulations. We have a team of people stood in the back of this room that pick up these rule books every single day of the week. They're engineers, but they're reading legal documents and interpreting them and turning that and translating it into meaningful language for engineers that says, you need to do this test, you need to do this test. Ultimately, these are decisions that manufacturer has to make, but helping guide and navigate manufacturers to get and do the right things to get their product to market. That's the US. In Europe, we don't have that terminology, intentional or unintentional radiators. We just have non-radio equipment and radio equipment. Now, I told you it's confusing, and here's the illustration. So, a non-radio transmitter, well, that's quite simple, right? It's either a transmitter or it's a receiver. But if you take your microwave oven, it intentionally transmits RF energy. It's just not for communication. It's actually for the treatment of material. In this case, to make water molecules vibrate and that friction causing heat, which is what we get hot food from. So the ISM is a type of intentional radiator that is neither for communication or radio determination purposes. Radio equipment in Europe, however, is anything that communicates, anything that you can determine the presence of something in front of you, behind you, anything like that, and anything that contains radio equipment. So I put on the slide there before a picture of a radio module, for example. And radio modules clearly are very common. Certainly if you're a host equipment manufacturer where for the first time you want to integrate some wireless functionality into your device. Let's call it a refrigerator. You now want a Wi-Fi module in there to enable you to go and order the next delivery of food, check what's in there, report out status, if the fridge is on, fridge is off, etc., etc. The fridge, by integrating the radio module, now becomes radio equipment itself. And I suspect for the majority of you in this room, you will be typically buying a radio module and integrating it into your product. And I'm also guessing that historically, you're not radio experts. Your whole raison d'etre for being a manufacturer of refrigerators is because of your knowledge of refrigeration, not radio technology. And what we find, therefore, is that's something that you guys come and need our help and support with. We interpret the regulations, we help and we guide you through all these different requirements because we recognize that radio isn't your first discipline. It's the thing that you make, whatever that thing actually is. I said there's some exceptions. There always are, right? I alluded to it with the vehicles before, right? So if I put a load of radio modules in a vehicle, the vehicle itself doesn't become radio equipment. If anybody wants to know more about that, that's probably a conversation in the lunch or over coffee. The reality is all IoT products typically these days are radio equipment. Most products, you're either, or you have already integrated radio into your product, or you're certainly thinking of doing that. Actually, just a quick show of hands. Who's a manufacturer? Who integrates radios into their product? Okay, pretty much everybody. And of those people that just put their hand up, who designs the radio yourself? Or who buy? Yeah, okay. So for those that couldn't see the hands, I would say probably 80% of you integrate radio into your product. And of that 80%, maybe 10 or 20% design your own radio. Everybody else buys a radio of some description and integrates it into your product. This is for you. Right, so in terms of regulatory frameworks around the world, we talked about testing that we do here for you to access a global market. Around the world, there are basically two regimes when it comes to radio. There is a USA model based around FCC rules, and we have a European model based around European Commission directives and regulations. I also said that we cover Canada, and Canada, from a regulatory point of view, is roughly mid-Atlantic. They like the FCC because they're the closest neighbor. They like their ties back to the UK and the wider Europe, and therefore have got a hybrid set of requirements. So what I'm going to be talking about really covers all of those three areas, but fundamentally, US and the European model differentiate the requirements. So, just a quick comparison between those two different things then. So, terminology I've sort of gone through already. In Europe, we talk about radio equipment. In the US, we talk about intentional radiators. In Europe, we have a single mark that is affixed to a product, the CE mark. And by you as a manufacturer putting that CE mark on your product, you are making a declaration that your product complies with all of the different European directives and regulations. One single mark. In the US, however, I told you that the FCC regulates the radio waves, but some of you are medical manufacturers, and the medical world is regulated through the Food and Drug Administration, the FDA. Safety is regulated by OSHA, which is the US equivalent of the Health and Safety Executive. And that results in multiple marks going on the product, even though it's just for a US or a Canadian market. So you have multiple marks, one for safety, one for medical, one for EMC, but it's all for the one geographic region. The other fundamental difference is, and I put largely for both of these things, is because largely in Europe, it's about self-declaration. And this is where Simon will pick up in his presentation when we start talking about risk. The text of our regulations, directives or regulations themselves, are not technical. They're to do with trade and commonality and free movement of good. And therefore, they're more aspirational in terms of their requirements. Thou shalt make safe electrical equipment. How you demonstrate that is largely down to you as the manufacturer. We have things called harmonized standards, which are a very convenient way of demonstrating compliance. But you could do mathematical modeling or simulation, another service that Element provide, for example, where rather than doing a physical test, you can supplement it with a modeling type test. The more safety critical something is, however, the more likely that we move from self-declaration into mandatory use of what's called a notified body. where the risk of you doing the wrong thing is so great, it's going to end in injury or harm to people or to property. So, for example, if you made something that was going on or in an explosive atmosphere, the risk of you applying the wrong standard, doing the test in the wrong way, is so great, we might end up with a Buntsfield or a Piper Alpha type of disaster. We don't want that, clearly, and therefore mandatory that we have a third party get involved, notified body, to act as an arbitrator in those circumstances. In the US, we have a Code of Federal Regulations, and the Code of Federal Regulations is both a legal instrument and largely a set of test requirements as well. It specifies the technical requirements. And it is certification. You do this and you follow these processes and do these tests, and you will certify the product. And once you've got that certification, you can sell that product forever in a day. You've got these grandfather rights that enables you, as long as you don't modify the product, to continue to sell that. That's a fundamental difference with EU legislation, where every single product needs to comply. If the standards change, state of the art changes, you're expected to update whatever those changes might be. So if I just go back then to how CE marking directives, I said that they're trade directives, they're non-technical, true. We base everything around what we call essential requirements. Thou shalt make safe product. Thou shalt make equipment that doesn't interfere with other things. That is the law. In one of these directives, and all the CE marking directives are the same, there's about 27 different ones, they provide some background. That's more explanatory text. Why have we generated this directive? What are the inputs that enabled us to create the directive in itself? And then there's some how-to-do-it guides, if you like, typically contained in annexes. Because you've got to meet essential requirements, the most common way of doing that is by performing testing, such as we do here. But I mentioned before, you can supplement that by doing some risk analysis. If you make a product that is used in the middle of nowhere, then what are you going to actually cause interference to, for example? And if the answer to that is nothing, then you don't need to do any tests. It gives you that freedom in Europe to do exactly that. And you have to document all of that in what we call the risk analysis file and your technical documentation to justify what you've done and why you've done it. And that is the evidence that you see on the right-hand side there. And the concept is that if anybody ever has any problems with your product, there's this concept that there's a folder, whether it's a physical or electronic folder, that you can hand over to a market surveillance authority and says, this is what we've done, this is why we've done it, and this is why we're not, why our product is compliant. And that's the whole concept of it. So in the case of radio equipment then, there are a number of articles or requirements. The Radio Equipment Directive is an all-encompassing directive. It just wants to make sure that any radio equipment, bear in mind again, radio equipment could be the module, but it will include the host if radio equipment's incorporated in it. We want to make sure that it's safe. We want to make sure that it doesn't electrically interfere with other things. And we need to make sure that the radio performance is such that it does not cause harmful interference. Meaning that these radio microphones all operate on a very similar frequency band, but they are channels. And if that channel drifts into another channel, a little bit like driving your car on the motorway, every channel is a lane on the motorway, and you have to stay in lane. If you start swerving from one lane to another, you're going to cause an accident. And essentially, the radio testing that we do supports exactly that, making sure you stay in lane and making sure that you keep to the speed limit or amplitude in this particular case. Those requirements have been around for a number of years. 2014 was the date of the directive. 2016 is when it's been implemented for. However, in the last couple of years, we've got new requirements. Those new requirements are the sexy titled cybersecurity. What do we not have a conversation about that involves cybersecurity these days? So they've implemented what are called delegated acts within the directive itself that activate Article 3.3 D, E, and F to make sure that fraud is not committed, that products remain secure, and there is no harm by hacking into something and taking control of the network and harming the network. A lot of the discussions that we're talking about in standardization and regulatory forums at the moment is around cybersecurity. And I'm pleased to say that in the next few months, we'll be launching our own cybersecurity service to support manufacturers when this becomes a legal requirement, which will be 2025. There's another additional requirement, which is what we call the common charger requirements. Common chargers apply to phones, tablets, cameras, headphones, headsets, all of those types of products. And that requirement comes in at the end of this year, on the 28th of December. And the common charger requirement is a bit of environmental legislation which negates the need for sending out another cable and another charger with every phone or tablet. And we have standardized on one single connector type, USB-C, which is why if you buy a phone these days, they are all got a USB-C connector on. It's because this bit of legislation and manufacturers getting ready for that. If you don't make a phone, a tablet, a camera, etc., etc., the rules will be extended to other types of electrical product in the near future during 2025, and that extends out to things like laptops and other electrical devices as well. So if you have a product that is running off DC, just an early warning indicator that it's likely that you will need to put a USB-C connector on there in the next year or two because the legislation is really driven by making sure that we minimize waste and improve our environmental credentials from an electrical perspective. In Europe, I said it's one mark and true, and we have one declaration of conformity. That declaration of conformity will cover all of the different rules and regulations that apply to your product. So if it's a piece of radio equipment, it's the radio equipment device, but equally if it's a medical device, then it's going to include the medical directives as well. Whether that be medical devices regulation, the MDR, or the IVDR, or active implantables as well. One declaration of conformity, one product, end of. And it's largely self-certification. There is no actual certification. We are a notified body. We have been appointed by the European Commission as a notified body, which is a higher level, but we do not issue certification. You don't come to us and say, can you rubber stamp my product? We, from an independent third-party perspective and technical experts, review everything that you've done, and if we think you've done it correctly, we issue what's called a type examination certificate. That enables you to create your declaration of conformity. The reason why we don't issue certification is because part of this is about ongoing compliance. We have no control of how you manufacture, whether you second source components, the variability of all of those things. We have no control of that. That's why it comes down to you and it's your declaration. As opposed to the US, I said the FCC, they cover RF exposure. One of the things that you'll see here today, which is a pretty unique capability in the UK, is what we call SAR testing. The assessment of RF exposure such that it doesn't cause harmful effects to us as, biological effects to us as humans, both humans and actually domestic animals, weirdly. Then EMC performance to make sure that we don't cause interference, and then radio performance in terms of the transmitter or intentional requirements. In the US, the FCC do not do quality tests. They only look at transmitters, they don't look at receivers. If your receiver doesn't work, then nobody's going to buy it. They're going to take it back to Best Buy or wherever the store is. This doesn't work properly, I'd like my money back. It's much more pragmatic and self-regulated in that respect. And it does not cover product safety. As I mentioned before, we have all of those different other safety regulatory marks for North America, and so they are additional to the FCC approval that you'll get. In terms of FCC requirements, I'll skip through this a little bit, various different parts. Part 2 applies to everything. Part 15 is for digital devices. Part 18 is those intentional radiators used as ISM, so microwave ovens, EDM equipment, those sorts of things. And then we have licensed transmitters, which are covered in the other routes highlighted on there. The US FCC has 2 routes to compliance. They have what's called a supplier's declaration of conformity, which weirdly doesn't actually involve a declaration. It's a process that you follow. So a lot of manufacturers come to us and say, could you give me a template so I can sign my declaration of conformity for the US? No, it's a process that you follow. It's just called SDOC. As opposed to certification, where again, although we're based here in the UK, we're also appointed by the US government as what's called a TCB, a telecommunications certification body, which gives us the authority to actually issue certification for radio, non-radio products for the US. Talked about Canada being somewhat mid-Atlantic, and there's some comparisons. The marking that you put on your product, IC or FCC, very similar, applies to transmitters, also applies to the non-radio parts of the device itself. And then in the case of FCC, I just said that we issue the certification. Element, we're also certified as an FCB, a foreign certification body for Canada. The difference is we do all of the work, we issue the certification, but our work is then checked by ICED in Canada as well. And then the product gets listed. In terms of other differences, very minimal. So yeah, applies, there are some exempted devices for low frequency products. And then for actual certification, here's the certification mark that must go on the product. But then we've also got, in Canada, some additional information that needs to go into user instructions as well. So given the fact it's a dual language country, Canadian requirements both require English and French warning signs and information as well, as opposed to just English for the US. So in terms of radio equipment, I'm conscious of time here a little bit, so I'm going to speed up. So first of all, I keep talking about radio modules, right? A radio module, effectively, you just need to provide power to it and some signals to it, and then you're good to go, a radio module. As opposed to a chipset, where it's got a radio, it's got an amplifier, it's got all of those things on it, but it doesn't have an antenna, doesn't have a shield over it, doesn't have buffered inputs, all those sorts of things. So there's a fundamental difference between a chipset and radio module itself. In the case of a radio module, both in Europe and the US, that is either an intentional radiator or a piece of radio equipment and is certified accordingly. You can put that on the market and it is fully approved. A chipset is neither. You can buy a chipset. Some of the timing requirements, if it's Bluetooth or RFID, you can carry over, but largely you've got to start from scratch. Module into a microwave oven. The microwave oven then suddenly becomes a piece of radio equipment. Now, it's hugely complex what you need to do when you put radio into a host equipment. We are leaders in a thing called the Radio Equipment Directive Compliance Association. It's a it's open to everybody, so anybody here can join. Element, however, takes very senior positions in that forum, and we lead a lot of the work and write the guides. So this guide here, for example, which is the European Guide on Integrating Radio Modules into Host, is written by my colleague Michael Darby. And then it's also backed up by ETSI, who are one of the European standards organizations, in terms of providing some more guidance as to what to do. Those two things directly interface and relate to one another, but Element very much leads the field and helps manufacturers and regulators and the standards bodies and helps them in terms of defining what those requirements are and the real nitty-gritty how to do it stuff. There is no company better positioned to offer guidance as to how to integrate radio into a host equipment. The guidance itself, I don't want to get too bogged down in the detail, but basically, when you put a radio module in something else, there are a load of tests that you need to repeat. Largely, it's down to you in Europe as the manufacturer to decide what those tests are. We can help, we can provide that guidance based on those documents that I've just referred to. But essentially, there are some tests that you can leverage and some that you'll have to repeat. In the US, as I said, we're a TCB. Here's an actual grant of authorization that we've issued to a manufacturer. It doesn't matter who it is. This is of a radio module. And the bit that you won't be able to read, but the bit that's highlighted on there, basically says, this is a limited modular approval. And it requires the integrator of the radio module into the host, and it tells them exactly what they need to do. It talks about, here's some guidance from the FCC, about when you do changes to the module itself by modifying the antenna, the PCB trace, all those sorts of things. And then there's also transmitter module authorization guide. I mentioned the fact that Element leads the way in Europe, but again, Michael Darby, who just happens to be one of the directors of TCB Council, wrote this on behalf and led the work in the preparation of this guide as well. So whether you're designing a product for the European market, the North American market, we're there to support you in every step of the way and can provide that very detailed guidance to help you. The information that was on the screen there, again, helps direct the integrator of the radio module and tells them exactly what they need to do. The antenna used for this transmitter must be installed at least 20 centimeters from all persons. End users must be provided with operating conditions for satisfying RF exposure, SAR testing. Only identical antennas with the same or lower gain can be used. So it's very explicit about how you integrate that module into the host. So if we start looking at what can go wrong if you don't think about these things then, if you start changing PCB tracks, for example, you get cross-coupling between the tracks themselves and start interfering between one trace and another. You can get reflection of the fundamental, which will increase the output, if you like. A little bit like noise-canceling headphones, where if the white noise is +1 and you generate something 180 degrees out of phase, 1 plus -1 equals 0. Principle of noise-canceling earphones. It's exactly the same when it comes to RF measurements. Yes, it might be 180 degrees out of phase. Very unlikely. Normally, it's in phase, and these things become additive, and therefore, we now suddenly have a much higher emission than was originally tested just as a module when it's been integrated into the host itself. Likewise, if you embed that module deep into your refrigerator, you may have made the receiver deaf, so it can't hear, which means the operating distance that it was designed to operate has now been reduced, and suddenly it doesn't work or is not as effective as it used to be. And then there are, like these radio microphones, near other transmitters that cause blocking effects. They start to drift into somebody else's lane, which means that become desensitized to the signal itself. So what does that mean in the real world? Well, if we took a normal spectrum analyzer plot, something at 2.4 gig, we've got a fundamental frequency. Here's another one, very similar frequency, but they're harmonically related to each other. And when you've got emissions which are harmonically related to each other, you start creating what are called intermodulation effects. So now suddenly, you can see that these spurs here start to produce electrical noise. Now, if this was a channelized system, that channel might be the difference between me and Matt's microphone, and suddenly I'm now interfering with him on one side or Joe on the other. So we have to think about that. The other issue is these additional frequency products which are generated, and suddenly now they're starting to cause interference in other bands. Maybe it's an emergency services band. Maybe it's a DAB or FM band. I don't know what it is, but you're creating new frequency products which need to be taken into consideration. There was our fundamental frequency originally, and now look what it's done to the fundamental in terms of increase the output. That means it's going to transmit further, yes, but now it's suddenly going to cause interference with other things. It might also then affect the RF exposure, the SAR assessment that's required. Doesn't come out particularly well. So then if I move on to the EMC side, good news, I'm nearly done by the way. When I move on to the EMC side, EMC testing, we're trying to make sure and do tests to simulate the real world. EMC testing is all about functional testing of your product, okay? We just happen to apply interfering signals to it to make sure that functionally it still works. But when we scan through a frequency range and we generate these big signals, we stop when we get close to where your transmitter frequency, operating frequency is. And then we start again on the other side. Why don't we do testing in here? Because in here, these are all the receiver tests that we do as part of the radio assessment for Europe. And by the way, if you're making and designing stuff for the US, historically they haven't had receiver tests and have interference problems and are very, very likely to start integrating and requiring manufacturers to do receiver tests like Europe, but for North America. So that's me. We've got Simon that's up next, and say Simon's going to talk about risk and pick up on some of those points that I've... Oh yeah, have we got time for Q&A? Let's do a couple of questions if there are. If not, you can collar us over the coffee break. Any questions, immediate questions? Great, Aunt. Oh, yes, go on, yes, yep. Front row here.
Hello, my name is Al from Indra. One of the things we fall short on prepping radio samples, radio equipment for testing. Have you noticed a gap between going for pre-compliance or full certification and what a customer need to do? And I just wanted to know if you've noticed that in your time.
I haven't even paid you to ask that question, but the answer is coming up in my second presentation, so I thank you for that. Is there anything else? No? Okay, great. Let's hand over to Simon then. Simon, we're having a break? Break first, not breakfast. Okay, so, seamlessly, there's a break that's been inserted. So it's through here, coffee, tea, snacks, help yourself, come back in 30 minutes, at 11, 30 minutes or 15 minutes? 20 minutes, we're cutting the difference. If you could grab a quick coffee, 20-minute break, and we'll come back in here for Simon's presentation. Thank you.